All right, Noah. So we're taking Avi's pull out of the ground. You got me, Gareth, you, and Avi. Let's say we can each squat 200 pounds. So in total, we're able to, lift it with a force of 800 pounds. Okay, now we're looking at a side view of the pool. Let's say we have this pole is the same height as this pole, so we don't have to deal with computing angles and components of x and y components of forces, but so that makes it bigger in the end. Okay, so we got an 8-foot 4x4 here. We have 1 foot on the left side of the fulcrum of this 4x4 and 7 feet on this side of the 4x4. I weigh 220 pounds and I'm just hanging on it. I'm not doing anything besides holding on. So we know the torque, or the moment from this force is equal to the torque from this upwards force into the pole, this force F. So we know the torque from me, 220 pounds times the distance, so 220 times 7. We also know the torque here is the force times the distance of 1. So we can solve for force, 1540, and that's your mechanical advantage. So, I mean, just looking at this, almost twice as much force. Assuming this pole, there's no angle here, it would be quite a bit lower. Because you'd have to do, let's say it's at an angle or something. You'd have to find this component instead of from this. This is my 220 here. I can't write with one hand, sorry. 220. And this would, have to be found by this angle, which would depend on the height of your fulcrum relative to the pole. But you could figure that out. But assuming you could get the same height, then it's easier to calculate.